Here. So thank you all for coming. Hello, I'd like to welcome you to today's presentation. I'm Laura Clark Murray. I'm head of partnerships with Omdena, and I'll be moderating today. So today's presentation is one in a series of demo days where our AI and data science teams are sharing the results of Omdena's work. Today, we're talking about a project done together with the World Resources Institute in support of their mission to sustain the natural environment for all people. I'm just going to move this slide. There we go. First, I'd like to explain a bit about the logistics of this 1-hour session. One moment, that is not what I want you to see. There we go. After this brief introduction, we have 3 presenters today from the project technical team who will present for about 40 minutes in total. This will be followed by a 15-minute Q&A session, and we ask that you please post your questions in the chat throughout the presentation, and we'll ask as many of those to our presenters during the Q&A portion of this session. I do want to let you know that this session is being recorded and it will be shared on omdena.com sometime in the next few days. First, a few words about Omdena. There we go. So Omdena is an innovation platform where AI engineers and domain experts collaborate to build solutions to real-world problems. For each of our 8-week projects, we gather a diverse team from around the globe to focus on creating solutions that have impact. Our customers have included the World Food Program, the UN Refugee Agency, as well as many NGOs and companies. And since Omdena launched a year ago, we've executed on 21 projects with more than 1,100 collaborators from 80 countries. Today, we're talking about a project that was done together with the World Resources Institute, or WRI, a global research organization that's working to sustain the natural environment for all people. Among its many initiatives, WRI is leading the way on land restoration, restoring land that has lost its natural productivity and is considered degraded. According to WRI, degradation reduces the productivity of land and it threatens the economy and people's livelihood. And so it can lead to reduced availability of food, water, energy, and it can contribute to climate change. Fortunately, restoration can return vitality to the land. And while significant restoration efforts are underway all around the world, local conflicts get in the way. Disputes about who owns a piece of land and disagreements about how any piece of land might be able to be used can stall restoration efforts. And though governments have instituted policies to deal with land conflicts, knowing where conflicts are underway and how each might be addressed is not a simple task. And that's the problem WRI asked Omdena to tackle. The purpose of today's presentation is for the Omdena AI team to share the approach they took to these issues and the findings of that work. WRI has shared with us that this work has served as a very helpful prototype for their next stage of development. Now, before handing off to our presenters, I'd like to introduce John Brandt, a data science associate at the World Resources Institute. We're so grateful to John, Kathleen Buckingham, and their colleagues for the opportunity to work on these issues with them. And we really appreciate John joining us today to share a few thoughts. And I'm looking to see.
Can you hear me?
Yes.
Perfect. Hi, everyone. My name is John Brandt. As I was just introduced, I'm a data scientist working at the World Resources Institute, where I focus on developing AI technologies for transparency and monitoring of forest and landscape restoration. We're really excited about the results from this partnership with Omdena. My team currently uses the code and infrastructure on just about a weekly basis. So I want to sort of extend a special thank you here to Joanne, Kali, and Rishika, and everyone else. I know there are about 20 or 30 collaborators on this project. Land conflict, especially conflict over land tenure, is a really large barrier to the work that we do around implementing sustainable land use agenda. Without having clear tenure or ownership of land, long-term solutions such as forest and landscape restoration are often not economically viable. However, getting data on where these land conflicts and land grabs and things like that occur is often very difficult because they tend to happen in remote areas with very strong language barriers and very strong sort of barriers around scale and things that occur in a very distributed manner. We're really excited that the results from this partnership were very accurate and very useful to us. And we're currently scaling up the results to develop subnational indices of environmental conflict for both Brazil and Indonesia, as well as validating the results here that we'll learn about throughout this next hour in India with data collected in the field by our partner organizations. We're really excited that this data can help supply chain professionals mitigate risk in terms of their product sourcing, as well as to help policymakers who are engaged in adaptive management to think about what works and where what works. While I have to run because my regularly scheduled monthly team meeting is occurring on another Zoom call right now, I'm really excited to watch the video recording of this demo call as soon as it gets posted, as well as feel free to reach out to me at my email, which is john.brandt@wri.org, and I would love to field any follow-up questions over email. I'm gonna turn it back to our folks at Omdena, and I look forward to watching the video call soon. Thanks. Bye.
Thank you so much, John. We're really appreciative of you being here. Okay. Excellent. And now, before I hand it off to our presenters, I just want to remind everyone to please post your questions in the chat as they're speaking. And now I'd like to turn things over to the Omdena team members who will present this work. AI researcher Rishika Rupam, data scientist Joanne Burke, and machine learning engineer Kali Prasad. Over to you guys.
Thank you, Laura. Okay, let me share my screen. All right, can you see my screen? Okay, so assuming you can see my screen, let me start. So thank you, Laura, again, and thank you, John, for that wonderful introduction to our problem. I think John spoke quite a bit about it, but let me go over the problem again once. Let me start with this image. It's the, as you can see, it's like a large landscape, and it's a very particular one. This is the image of a degraded land that has been partially restored by villagers in the state of Maharashtra in India, along with the help of this organization that does land restoration. So let's just go over some of these terms. What is degraded land? Well, degraded land, according to WRI, is land that has lost some degree of its productivity due to human-caused process. And land restoration, on the other hand, is the process of ecological restoration of a site to a natural landscape and habitat, safe for humans, wildlife, and plant communities. So over here, you can see that parts of the land are already restored. They look green, but part of it is still degraded. So WRI is working with its partners to restore about 500 million hectares of deforested and degraded land, an area that's about half the size of China. Okay, so land restoration happens in response to land degradation. Let's try to understand the scale of the problem of land degradation. Well, globally, land degradation affects about 3.2 billion people and costs 10% of the global gross product. If we focus our attention to India, where this project really focused its attention on, India has nearly 140 million hectares of land that could potentially be restored. And in fact, the government has committed about 21 million hectares of land for restoration, and this was later revised to 26 million by the year 2030. Okay, so this looks great. You have some land degradation, but there's the commitment to land restoration. But the problem is that to go from land degradation to restoration is quite challenging. And one of the main concerns is this problem of land conflicts. What happens is that sometimes it is the case that land ownership issues crop up as a result of sometimes a conflict between the government and public, or sometimes personal conflicts between landowners. It sometimes happens that land restoration is made difficult due to a conflict between humans and animals. For example, humans invading habitats of tigers, leopards, or elephants. Or sometimes environmental factors like floods, droughts, or cyclones. All of these contribute to land restoration being difficult. If there's this another great platform online, it's called Land Conflict Watch. And on their website, they have this wonderful schema that you can see over here about the different kinds of conflicts that happen. They're part of mining, power, land use, and so on. And so land conflicts affect land restoration directly, but also indirectly, because it's too vast and too varied. These conflicts are too vast and varied, and it becomes quite difficult to keep track of what conflicts are happening where and who is being affected. So the goal that WRI set up was first to identify land conflicts in India and match them to specific policies. And by policy, I mean by the policies that government set up to deal with any of these issues. For example, here's a policy, the Protection of Plant Varieties and Farmers' Rights Act, that deal with, well, plant varieties and their breeders. And so the goal is that whenever we encounter a conflict, we should be able to tie it up with the policy that's related to it. So in this case, if we come up with a land conflict that's related to plant varieties or its breeders, we should be able to match it with this specific policy. And once we do this for each conflict, we should be able to make this data easily accessible to the people in power and the people who are actually who will actually be in a position to affect some change. Okay, now let's try to understand the scope of the problem. Currently, India is home to about 1.35 billion people. It has 28 states, 22 languages, and more than 1,000 dialects. So in a land as vast and varied in India, how does one go about gathering and collating this information about land conflicts? And if you think about it, the most natural place to begin such an endeavor about gathering information about events is newspapers. So this was the idea that WRI had, is to collect information about ongoing events about India from this online platform. And there's this wonderful platform called GDELT. GDELT stands for Global Database of Events, Language and Tone Project. And basically what GDELT does is gathers all the newspaper articles from all over the world in several languages, English and other languages, and converts them to different languages as needed. And so WRI got about 65,000 articles from GDELT from India for the years 2017 and 18. And their idea, once we had this data, the goal of the project became more sharpened. And I really must kind of thank WRI at this stage, because their definition of the problem was so sharp and refined that it really helped us to kind of further sharpen the project and take it to the next level. So their project definition was really nice. And so our goals became more concretely to be able to classify news articles as pertaining to a land conflict or not. And once we have that, to identify among those news articles who the key actors, events, and locations are. So who is it affecting, and what are the events, and where are they taking place? And once we have all of that, to be able to match the conflict with the right policy. And once we're done with all of this, to be able to make all of this data easily accessible in the form of an app or a tool. Okay. Now, well, a lot of you might already be convinced that machine learning and AI is the obvious choice for solving this problem, but a lot of you may not be, and it's absolutely valid to have that doubt. And to understand why we need machine learning and AI, let's talk about a specific news article and what we need to extract from it. So over here, let's say we have this article. It's a fictional article about a tiger attacking a farmer. According to the goals we just set out, these are the things we need to do. We need to classify this article as positive because it's talking about an actual conflict. We need to identify tiger and farmer as actors and attacked as the main event taking place. And then we need to match this article to the right policy. In this case, it's the National Wildlife Action Plan. And once we have all of that, we should be able to display this and other articles like this on a map. So based on the location of this particular news item, we should be able to display it on a map and to be able to visualize this data. Okay, so now why AI? So, well, you can tackle this problem without the use of any automation tools. But imagine doing this for 65,000 articles. Well, it would frankly take years to go through all of them and marking them as positive or negative, identifying the events and actors and so on. Whereas it took us about 2 months to actually develop a model. And moreover, once this model is developed, we can feed in another set of data and just feed it into the model to get the results. So we don't have to keep reinventing the wheel each time. Moreover, this is, I think a lot of you may have already heard of the term natural language processing, which is basically the field of study in which we use machine learning or deep learning techniques to solve text data. And a lot of people are now fond of saying that this is kind of the golden period of natural language processing. And maybe you've seen examples of chatbots who talk to humans in a nearly human-like way, or examples of machines generating poems at will. And in fact, it's true that natural language processing has really made tremendous leaps in the last few years. And to be honest, what better way to leverage this growth than to use it for a project like this, for a for good project. And we truly believe, in fact, that this particular project is like the right marriage between the right use case and the right technology, because after all, what we're doing is using machines to tackle a huge amount of text data. Okay, with that, I'd like to hand over the mic to my colleague Joanne, who's going to go over some of the technical details of the project. Thanks, Joanne, and over to you.
Bear with me as I get my screen. Can everyone see my screen? Yep. Very good. Well, thank you, Rashika. It's been an honor and a privilege to work with you and my other teammates on this WRI project and use my AI skills to do some good deeds and good work in something that's going to have a global impact. Now that Rashika has framed what is the business question, we have a strategy that was developed as our team in order to use AI techniques to solve the problem.
Joanne, I'm just going to pipe in and ask that you speak up a little bit, please. Thank you so much.
Is this better? Yeah.
I think so.
Okay. Here's our AI strategy in order to solve this problem. The first step is to look at news articles. And within these news articles, we need to prepare them for an AI pipeline where we can take news articles and classify them as a land conflict or not a land conflict. Using a Docano tool, the team hand-labeled 1,600 newspaper articles that were on the website provided to us by the GDELT database. It was a team effort. It took a week, and 10 team members jumped in order to hand label each one of these articles so that we could have a classification model developed based on these hand labeled articles. So what you see here is an example of a positive article. A negative article might be something about border war or local elections or a Bollywood movie. Those would be labeled as negative. Positive would be something pertaining to land conflict. Here we see a tiger attack. A tiger attack has to do with human-animal conflict and safety in rural lands in India, so it's very pertinent to defining what a land conflict is and linking it to a policy. In order to prepare the articles for a classification model, we use TF-IDF. It is a method to take a word and define it based on the frequency within a text and the inverse document frequency. It's known as a bag of words approach. And also to pre-process the data, we removed common stop words such as and, the. There's a standardized list of about 200 different stop words to remove. We limitized words, which was taking a word and looking at the root form of the word. This way, we will have more instances of a particular word, leading to a more effective TF-IDF word frequency vectorization. We also used a co-reference pre-processing. And surprisingly, this did an amazing job improving the model's accuracy by 10%. We were able to find instances of pronouns, refer them back to the noun that they were referring to, and thus increasing the word frequency and allowing the model to be more accurate. Bag of words, however, doesn't have any semantic context. That is, there's no definition of the meaning attributed to the content, the form, or the style of the text. Any negative words not or didn't aren't taken into account. Sequence models, on the other hand, would take this into account, though they require more processing. In order to understand what the issues were for our land conflict, here we have used a topic modeling approach. Among the gold standard articles, the 200 positively identified articles that we were provided by WRI, and we were able to define these 7 issues that relate to land conflict. Forestry, which is a long-standing issue in restoring forest lands in India, land, wildlife, human-animal conflict, water, drought, farming, and mining. These are found again and again among the articles, and then we're able to actually go back to WRI and suggest that they add additional policies because these there were some policies, or there was a lack of policies in addressing these issues that AI was able to uncover. So how do we evaluate our model? Traditionally, this type of model has an unbalanced distribution. We have a lot more negative values than positive values. Among the articles, we could only find a third that were pertinent to land conflicts. And so using traditional accuracy measures was misleading. Instead, we used an F1 score. An F1 score will take into account false negatives and false positives. This is a typical confusion matrix. Taking account precision and recall. A false negative can have some big implications in that a false negative, you would lose nuances in articles and you'd miss developing and new events. If you have false positives, you might be following the wrong content, those that weren't pertinent to the cause. So it's important to understand what is causing false negatives and false positives and reduce these parts of the confusion matrix. Our classification model attempts first started with classroom learnings. Some of you have taken Andrew Ng's deep learning class. This is a bidirectional LSTM model. It's a cutting edge technique that is taught for in deep learning approach. And it's one that I and a teammate tried to develop. We had an F1 score that was in the 75% range. And this is kind of sobering when you're used to seeing 90% plus accuracy rates. So we realized that we needed to revisit and figure out a different model approach. Here you see a lot of false negatives. These are, in actuality, 26 positive articles that were flagged as negative, so we'd be missing a lot of content that would be important. Just side note, we were able to increase the accuracy a little bit with co-reference resolution and looking at dropout rates. Dropout rates are an important consideration in LP. For our second modeling attempt, we went to industry. In the past 3 years, there's been a great amount of progress in NLP. The BERT model is a go-to model. And it's a cutting edge model. You see BERT, UML, someone else tried the UML fit model and all the other derivative models. And we were able to get better F1 scores, so we were happy. The best part of it was that we were able to get better recall. So we had fewer false negatives here, so we were able to better define what is a positive article. So this was definitely an improvement. The issue was this was 4 epochs that ran for 6 hours. So the practicality of running this model came into question a little bit. The model file and implementation was 1 gigabyte. There are definitely ways of implementing this, and BERT is an excellent go-to if you have the capabilities. But the third part was from real-life collaboration. There were some experts in the field in LP who were able to build a logistic regression model that was optimized for L1 and L2 regularization. and just input bag of words, which is also a simplified way, simplified input instead of a sequence model. And they were able to achieve F1 scores in the 97% range, which was fantastic. And in the long run, this would be a lot more maintainable. And our second part of our strategy was per the request of WRI, identify the key actors, events, and locations that these conflicts involve. Entity recognition goals were to define the actor, the number, any number values, actions, and locations within articles. We decided that type was very broad, and we had already covered that through other methods in the process. Here we see the DocAnno tool again. We were able to bring up the articles, and with the efforts of an outstanding team again, we took to the task of labeling these articles with those 4 items. There were 147 articles that were labeled this way. And you can see here, excuse me, and you can see here actor, action, and number were indicated through hand labeling. After hand labeling, we were able to indicate which were the actors among subsequent articles based on the labeling efforts. Thousands was flagged as a number. Protesting was flagged as an action. Police, farmer, and government were flagged as actors. Once we were able to complete this task, the last task in our strategy was to match the conflict with the right policy. Our approach here was to take a list of policy documents These policy documents were in the PDF form. We were able to convert PDF to text documents, clean up these text documents, and use a cosine similarity to find the similarity between the news article and the policy documents to get a similarity score in the range of 0 to 1. Based on the score, we would identify and list out those policies that were most pertinent to that article. And finally, after we have built our AI model pipeline, we needed to build a tool to visualize this information. To pull it all together, we started a new task, and Kali Prasad led the dashboarding effort. Please welcome Kali. He will do a demonstration of the WI dashboard that connected the web-based articles to policies using our AI models.
Yeah, thanks, Jonna. Let me share my screen. Okay, I hope you guys can see my screen.
Yes, we can.
Okay. So, hi guys, this is Kali Prasad. This is the tool that we built during our challenge with WRI team. So here you can see a lot of data. This is the data table, and here you can see India. We can zoom in and zoom out this map, world map. In this project, particularly, we have concentrated on India. So you can see all the points plotted on the map. So basically, let me explain you the data we are using in the backend. As Jonna has already explained that we are using the data from the GDED project. So what is GTED project? It basically does was it collects all the articles or events that is happening around the world. Whether it may be at the print media or electronic media, it basically collects all the events. So you can say it is a huge collection of database. It's a huge like collection of these events, huge database. So, and you can access these database and you can do analysis in like Google Cloud. But for that, you need to have some SQL knowledge and some machine learning NLP skills to do the analysis and everything. And with this tool, we can simplify that. You don't need to have SQL knowledge. The end user can like directly can access with this tool without any knowledge of SQL or machine learning. So here, basically, you can see two filters. One is like year filter 2018 and 8 and 17, the data we have taken from GDL. And here you can see all the states that are available. So based on these two filters, you can get the articles. So let me like click on Jammu and Kashmir. So here you can see the app is updating. So what it is doing was it in the backend, it was getting all the events or articles that belongs to these two filters. As you can see, the app got updated and previously they are only for Andhra Pradesh. Now you can see for Jammu and Kashmir and it belongs to 2018. And it also has the Andhra Pradesh as it is one of the filter. Similarly, you can select n number of all the available states and the years. So this app has mainly two parts. One is the data visualization part, which is like matching the conflicts and building this visualization tool. And the other is the machine learning part. So to show you better, let me fix with the Andhra Pradesh and 2008. So here, these are all the categories that are available. And for each category, we have the different color. So if you want to concentrate on only on the single category, what you can do is like you can triple click this area and all the plots will be disabled. All the points will be disabled. So suppose if you want to see all the agricultural events that happened in Andhra Pradesh in 2018, what you can do is like you can click on the particular, sorry, I have clicked on the moment. You can click on the agriculture and it will plot all the points. Similarly, suppose if you want to see the environmental events, you can click on it and it will plot all the points dynamically. So here by just visualizing, you can say that in year 2018, Andhra Pradesh, the number of conflicts like agricultural events are more than the environmental event. So, and similarly, you can compare like other things, suppose like health and these things. Okay, now if you want to show someone, what you can do is just you can click this camera picture and it will take a snapshot and it will allow that image to download from the server to your local machine. As you can see, that image was downloaded. Part. So here now we have like lots of data available here. Each row represents an article. So let me like here like total you can see total 43 pages of data is available. So if we see the let me click on this first point. So when I click on this link, the app is updating. So what it was doing was if you see here is a source URL for that event. So this app goes to that particular URL and grab the article and gives the text to the backend machine learning model. So here in the backend machine learning model is the logistic regression model which we are using. So it gives this whole article into that machine learning model. Here our machine learning model has predicted the article is negative. So let me explain you like what does it mean by positive and negative. Here the positive means this article talks something related to environmental conflict or something like land or farmers or something like this. And if the article speaks other than this, like sports or politics, any other than this, it will predict as negative. If the article speaks something related to environmental, our machine learning model will predict as positive. So here already if you can see it has predictor. So let me go and select some other article. So it belongs to some agriculture. Let me click on that. Here you can see it is updating. So okay. As you can see, we got that. So it grabbed that article, it went to that URL, and here you can see that you can read the article here. So this was talking about something related to 24 hours power supply and something related to farmers, and it is in Hyderabad. So our machine learning model has predicted it as positive, and it also gives us the policies, recommended policies. So the first recommendation policy we got is like protection of plant varieties and farmers. So protection of farmers related this, it is saying that this article related to this policy. And it also gives us the cosine similarity values, like the highest the cosine similarity value, the better is the recommendation. And without reading the article, you can get sense of that article by seeing this topic modeling. So that it's saying that this article mainly, maybe it was for water drink.
Kali, we seem to have lost you.
We want to include more features. Okay. Hello.
Okay, you're back.
Yeah. Oh, okay.
Thank you. You're good. You can carry on.
Okay. I can carry on. Okay. Okay. Did you hear about this? All this topic modeling and everything? Where did I stop? Like?
No, we're good. We heard that.
Okay. You do. Okay. Fine. Yeah. So our machine learning model, apart from giving this like prediction, negative or positive, it also gives us the policies recommendations and their cosine similarity values. And also it gives us what the article is talking about. Like without reading the whole article, you are saying that, okay, this article is talking about like water drinking or some damn things. So in future, we want to include more filters here, and we also like include like word triggering and attention mechanisms to our model, so that it will be more intuitive. So yeah, that's it, guys. Now I think Jonah will take.
Yes. Thank you very much, Kali. That was an excellent dashboard that you led in developing. We're so happy with it. After 8 weeks of collaboration, we still have things that we wanted to do and to add to the model. Data volume, we'd always like more data. We had looked into data augmentation, where we would add similar text corpuses in order to get more instances of positive and negative articles and more hand labeling of positive and negative articles. But our logistic regression model was extremely accurate, having very high F1 scores as it was. Data quality, we'd like to resolve more of the named entities within the text and add to more policy documents when we can uncover interesting nuances in land conflicts and how we can relate them to policies and take action. And pre-processing the policy documents more in depth. There's a lot of verbiage that's involved in the policies. Data modeling, adding attention mechanisms like distilled BERT, which will have faster run times than a traditional BERT, or refining cosine similarity metrics. This would also be something we'd like to add if we have more time. And of course, spend more time with like-minded data scientists, machine learning engineers, and AI experts. It was a wonderful experience. Our final model dashboard are at RI, and we are so excited that they are using it. We are able to connect the conflict articles to important policies using AI methods. And we have found a way of using AI to forward a good cause that affects people globally. Here are our team members. They're from around the world. They're AI experts, data scientists, graduate students, and data engineers. And it was just an exciting team to work with. And more than 50% of the team were women. And in this industry, that's a real win. So we were excited about that. And here are some of the faces behind the efforts that were put forth in completing this project.
Okay, thank you, Joanne. Just going to share my screen and present. Okay, so thank you so much to Joanne, Rashika, and Kali for their presentation and sharing that work. We really appreciate it, and the efforts of the whole team that's behind this. And now I'd like to introduce my colleague, Josena de Oliveira Gomez, who will oversee the Q&A. She's been monitoring the chat and will lead that section.
So hello guys, and thank you so much for all your questions and for staying with us this afternoon or morning or evening for this very interesting discussion. So I see many questions in the chat and I'll try to cover all of them, but let's go maybe in the direction of how the project worked. So I will start with the question from Asad Jamil. I hope I'm pronouncing your name correctly. It's a question on the data sources. So the question is, what portion or percentage of the source, of the news articles, were from local papers and what percentage was from national scale? And also, was the selection of those news articles random? And or was it filtered through like this specific topic? So I don't know if Joanne or Rishika or who wants to.
Yeah,
And I'm so sorry, Rashika, before you answer, I just want to pipe in and say, Joanne, when you do answer one of these questions, if you could speak up as much as you can, that would be really great. We're having a little bit of sound issue when you speak. Thank you.
Okay, so for this project, all of the data was actually provided by WRI, and as I mentioned, like they pulled their data from GDELT, and I know that the data was a mix of national dailies as well as the regional articles, but I don't have it in my mind right now what the percentage of breakup was, and I don't think there was a filter, so we had like for all of the newspapers that were selected, we had all of the news articles for the year 2017-18. So a lot of them were like, had nothing to do with land conflicts. And, but like a certain percentage had to do with them. So I don't think there was a filter. Yeah.
Thank you. So I'll go to the second question is a question from, let me just find the question, from Anna Harsberger, and it's a question about policies. So she asked, what do you mean by matching conflict with right policies? And also, how did you collect all the policy documents? How comprehensive was this data collection for the policies specifically?
I can take that.
Okay.
Well, initially we were provided 17 different policy documents pertaining to land conflicts. And the majority of them, of course, had to do with deforestation efforts that have been underway for many years. But then we uncovered that there were actually other events that were happening within India that were pertinent to land conflicts, and we brought those to WRI's attention, and then they gave us 5 additional policies to add to the corpus, where we could broaden the number of policies that were important and should have eyes on pertaining to the newspaper article content that we were saying. So I had to do with how to deal with foreign borders, and there were some issues because of the diversity of the population. There were a lot of rules and regulations, and they had to kind of be brought into tie into one particular policy and to be more cohesive, to allow for a more standardized approach to issuing, especially when it came to do with issues of land borders between farmland and those type of issues that we uncovered.
Okay.
These are legal documents that we were provided. Yes.
Okay, cool. Thank you, Joanne, for the detailed explanation. So now we go to the third question about the location, or the how did you identify this geolocation. This is a question from Tim Gordon, and he asked specifically, how did you geolocate the events? Was this based on GDELT metadata or in the article's publications?
I think both. There are two places where we identified the location. I think I can answer for the entity recognition. Many of these libraries have like an automatic place detection. So Spacey in their entity recognition, I think one of the standard entities is GPE, or geopolitical entity, and that's the one we used for places. But I think the one that Kali used, I'm not sure. I don't know if Kali
Yeah,
wants.
Yeah.
Okay, you can
yeah,
go.
yeah. Actually, in the GDEL project itself, they gave us the concrete event location, latitude and longitude. So for the visualization part, we took that longitude and latitude location, and we have plotted it. Yeah.
Okay, thank you. Guys, then now the next question would be again another question from Azad Jamil about the hand labeling. Sorry. So this is a question specifically for Joanne. So when you say that the team hand labeled the articles, do you mean you use machine learning engineers or domain experts for doing this job?
Oh, that's a great question. It is a tough task that's involved in any classification model, and Rishiko was a real advocate of this too. There's a Docano, and Docano is able to take the articles and load them up and then put a nice user interface, and you can read the article content. And from there, you can select positive, pertaining to land conflict, or negative, not pertaining to land conflict. So hand labeling was enabled. It was a little bit of a nicer interface, but it is a very important part of the process. We were provided 200 gold standard articles, which were positive articles. We were not provided any negative articles for comparison, so we had to develop our own. And a lot of it is based on the accuracy of hand labeling. So you have to first have some understanding of what the content of the data is and how it relates to the business question. And you have to look at the content of the article and decide for yourself. Now, first pass through, this is a little bit difficult, so we required 2 passes. So 2 people had to have eyes on the article.
Okay, I see. So I hope this answers your question. The next question is a little bit about the tools for the identifying the degraded and non-degraded regions. So this is a question from Mina. Mina, I saw that you were having some trouble to hear. I hope you can hear better now. So Mina asks if you could provide some information about the tools you use to assess the status of the land, like if it's this classification, if it's degraded or non-degraded, and the degree of land degradation, if this was considered in the project.
We didn't deal with the part of classifying land as degraded or not. We were mostly just talking about where the conflicts were happening. I imagine that at a later stage, WRI would match the degraded land with the conflicts, but that was not part of our project.
Thank you. Next question is going to be a bit about the kind of the development of the project. This is a question from Satish Shimhadri. I hope I'm pronouncing your name correctly. The question is about how the team collaborated, how was it coordinated, what tools were used for this coordination, and what were the challenges that you faced across this project?
Yes.
And how the work was divided, I'm sorry.
Yes. Hi, Satish. Thank you for joining. we collaborated as a team. It was an interesting type of approach. We used Slack channels to have weekly discussions. We had a great kickoff call with all the collaborators, and everyone had ideas about approaching the project. Everyone has a different strength and a different background. Docano is an interesting utility that someone was able to add to the project pipeline. Everyone kind of contributed, and it kind of started to be individual efforts to understand the problem, but then we would create tasks. And from each one of those tasks, we would have team members that would participate in tasks as they came up, and where their strengths would lie, and they would jump into that task and try to approach it from a team perspective and add their skills and background and understanding of the project. So it kind of gelled together.
And I'm gonna pipe in here just to add on to what Joanne was saying. All of this work was done in the framework of Omdena's platform. So that is precisely what we're fostering with these projects, which is this collaboration of these teams of extremely diverse teams from all over the world collaborating together, and we have a whole framework within which that they work, and that we guide the teams through to focus on the problem along with our partner. So I'm happy to answer any questions about that process. Feel free to email me. It'll be on the next slide when we pop that up. Thank you.
So, so the next question, like we are approaching the 1 hour, so I'll try to keep it short, maybe 1 or 2 more questions. So Anna Hasberger also asked about what about the conflict between international companies and farmers? Was this considered as some sort of land conflict, or was this not part of the project? And also in this direction of land conflict in a degraded area, if what about the land which is degraded after forest fire, like in Australia? So was this considered, or is this something that you guys have in mind, or yeah?
Yeah, so you're right that for a lot of news articles, it was not very clear whether they would be classified as environmental conflicts or not. And it really depended on the article. So if there was a conflict and it involved some land or environmental aspect to it, then we would classify it as a positive article. As far as like forest fires, what would happen? Yes, I guess it depended on the news article. If like there was like a conflict within the news article, we would identify it as positive, or not otherwise. Am I right, Joanne? That's pretty much what we did.
Yeah. There were some events, typhoons and floods and issues that also led to land degradation that were flagged.
Right. Okay. Yeah.
Thank you, guys. So now there was a question that was already answered, but I would just like to mention that it was about the documentation, or where would be possible to find more information about the project and about the neural network that was generated and so on. So this was already answered by Laura in the chat, and I don't know if you guys want to comment a little bit about your white paper that is in progress.
I know that on the GitHub page, we have all of the code, and basically you can anybody can just go in on there. So it's like the Omdena GitHub and then Omdena/WRI.
Okay, thank you, guys. And thank you all for all your questions. This was a very good presentation, and also the very good questions for the discussion. So I'll give it back to Laura now for the closing.
Wonderful, thank you, guys. Yes, so I posted in the chat the URL. I'll do it again, where anyone who's interested in learning more about this project can go to that page, and there is a downloadable white paper that was encapsulates this work. And of course, we'd be happy to have any follow-on conversations. Feel free to email me. My email is up on the screen right now. And I also, so I do want to thank everyone for attending today. We really appreciate it. We're so appreciative of our partners at WRI and the fantastic work that this team did, and really appreciative of our presenters today, and Hosanna as well for her help in putting this on. And finally, I want to point out that, as I mentioned, this is one in a series of demo days, and we have another one coming up in about 2 weeks, where we'll be talking about, it's another natural language processing project, as a matter of fact. We did work with the World Energy Council to understand the sentiment of people around the world about their role in the global transition to clean and just energy. So we invite you to come. The URL is on the screen. It's the same one that you would have gone to for this event, and we hope you will join us then. So thank you so much, and until next time.